Hi everybody, my name is Josh Iskander, and today we're going to be looking at the differences between making hard candies, soft candies, and all that kind of fun stuff. So basically, the main difference between candies is whether sugar crystals form or if they don't form and what size they do end up being. So how do sugar crystals form and what causes them to make these different sizes when the syrup is cooled down? In order to better understand this process, we have to look at it at a more molecular level. So let's assume we can see this at molecular level. Each single grain of sugar consists of small crystals made of an arrangement of molecules called sucrose. Sucrose is a type of carbohydrate, and the basic unit of a carbohydrate is just a monosaccharide, or commonly known as a simple sugar. As you can see in the figure above, this is how sucrose looks. These simple sugars can be linked in many different ways, and sucrose itself is a disaccharide made of glucose and fructose.
So what are we going to need today for our experiment? First, we're going to need a measuring cup. I'm using just a single cup measuring cup. I got some filtered water just to make sure there's no impurities in it, so there's no crystallization that we're not looking for. Just a small saucepan. We need some white sugar. And lastly, we're going to just use a thermometer that should get up to around 300 degrees so we can accurately measure our sugar.
So the dissolving process happens in two steps. First, the water molecules bind to the sucrose, and then second, the water molecules pull the sucrose away from the crystals and into solution. Now, what we don't want to happen is have there be too much sugar put into the solution where it can no longer dissolve into the water, and then this would cause the solution to be what we know as being saturated. And if it's saturated, then there would be crystals that would form and unwanted impurities that would cause recrystallization before we needed that to happen.
So to start off this experiment, we're going to get 1 cup of sugar and put it into the saucepan. So do that. Then we'll add 2 parts water. So for this case, it'd be 2 cups of water. Then we'll turn on the heat and allow it to start to dissolve in the solution, and stir every now and then until the sugar is fully dissolved. So we're just going to stir it. And it should dissolve pretty quickly in this solution.
So as the solution's boiling, let's talk about a little bit of the chemistry of saturation. So as we add more granulated sugar to the solution, you'll see that the rate of the dissolving decreases. And this is because the crystallization is increasing. So at some point, both the rates are equal, and in other words, the number of sucrose molecules that are leaving and the crystals that are increasing are the same. And that's when we see this process called saturation.
So now we see that the solution is starting to boil. So I would just recommend taking some temperatures to see what you're working with. So for our first temperature, we're trying to imitate a softball stage of sugar, which is between 235 and 240 degrees. And this means that the concentration of sugar is around 85%. And when this solution is at that temperature, that's when we know that it's a softball stage, because it will have, when you drop it in cold water, it should create a soft ball, hence the name. And this is good for fondants and fudges, more like a soft, sweet, sugary flavor. So right now, the solution is at 188 degrees. We're just gonna turn down the solution a little bit to let it boil a little bit slower. And we'll read the temperature again just to make sure we're not above our threshold of 235, which is where we want to be at for our first experiment. And we're around 210, so I'm just going to turn it down a little bit lower, because we only have a degree of air of 5 degrees from 235 to 240. We have now reached the softball stage. So we will, to test this, we're going to, I guess, first take the thermometer out, and then stir the solution, and then we could place it directly into cold water, and we'll see how it hardens. Add a little bit more just to test. We were not able to get to the softball stage, and this error could be caused by many things, most likely the thermometer not reading correctly. So I could have possibly gotten a digital thermometer. I had to actually get this analog thermometer because the other one went out of commission because it got water in it. But yeah, so the softball should have been not brittle and able to mold. So although we weren't able to make the soft candy like I was trying to make, the crystallization process is still explained by Le Chandelier's principle, which basically states that a system that is shifted away from equilibrium acts to restore its equilibrium by reacting in opposition to its shift. So an increase in the temperature of the system causes a decrease in the energy in an attempt to bring the temperature down. Because the breakup of chemical bonds is always absorbing energy, it cools the system down, so more sucrose molecules are able to break apart and dissolve in this solution. So what exactly happens when we put the solution or the crystals into the solution of water, the cold water? At this point, the sugar crystals form. This is also explained by Le Chandelier's principle, where a decrease in temperature causes the system to generate energy. And in an attempt to bring the temperature up, because the formation of the chemical bonds always releases energy, more sucrose molecules will join the crystals in an attempt to increase the temperature. This explains why crystals form when the temperature decreases. Once this saturated solution starts to cool down, it becomes super saturated because there is more solute, which is the sugar in this case, than the solution, which is water. So at this temperature that it decreases, the sugar comes out of the solution, forming crystals. The lower the temperature, the more the molecules join the sugar crystals, and then this is basically how rock candy is formed, which is what we ended up making instead of what I initially had aimed to make, because my thermometer wasn't as accurate and precise as I needed to be, which is definitely my main source of error. I hope you enjoyed, and thank you for watching.